star versus delta connections. So let's look at our let's turn a pen on. Just give me a second. Black. Okay, so if we've got three lines here, line 2, line 3, and a neutral. So this is typical of maybe the lines coming down your road, and then we generally have one phase into a house, so we bring a neutral into a house and maybe this phase, and then your neighbour might take the next phase and your other neighbour take the next phase. So we all have single phases, and that gives us 230 volts between a single phase and a neutral. If you're a commercial operator, you may have three phases, which gives you the option of having 400 volts. So let's draw that in. So if I lived here, if I measure between here and say the neutral, 230 down to the neutral there, that's right, one phase to neutral. Or I can go between two phases. I can go between two phases, so those two phases, and I get 400 volts. And there's a relationship, and there it is there. So this one here is called our line voltage. When we're measuring between the lines, that one there would be called a line. And this one here we call our phase voltage when we're measuring to a neutral. Okay, so we've got a line voltage, 400 volts between the lines, and we've got a phase voltage, and there's a relationship between them, and that's root 3. But what's important is, what I wanted to look at is, because you guys are studying that in 3104 or 3 or no 6 or something, but I want to look at the relationship between the power. Okay, so if we grab a lamp, say a lamp of say 20 ohms, I'm going to put a 20 ohm lamp here. Okay, it's a 20 ohm. Or and we'll also compare it by putting it between our phases. So this one here is going to be 20 ohms again. Okay, so what have we got here? Let's look at this one here first. So this one here's got 230 volts across it, and this one here's got 400 volts. So I want to see how much power we got on that lamp. So P equals V squared over R. That's in this case here, okay? This case here, which will be 230 squared over 20, which equals, boom, 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 boom. It's about 206.45 watts. 2 and 3, 2 and 2/3 of a kilowatt, say 2 and 2/3 of a kilowatt. It's almost 2666. Okay, let's have a look at it if we are looking at the other lamp. So there we've got on the 230. What happens when we put the lamp across 400 volts? P equals V squared over R, which equals 400 squared. It's squared, so it's going to make a big difference. Still over the 20, which comes out at 8,000 watts, which is 8 kilowatts. Okay, so what's the relationship here? 2 and 2/3 to 8, the relationship is 3. So we get 3 times more power when we're going across the lines than if we went from line 1 to neutral. Okay, if we just went to a phase voltage, or if we went line voltage. So if we have a commercial premises where we've got 3 phase, we can get 3 times the power. Okay, that's why we're using 3-phase motors. And whenever we have 3-phase available, we prefer 3-phase motor. And there's some benefits in how we hook it up. So we're going to go on and we're going to look at that in a minute. So I'm just going to stop this one here because it's getting a bit long. Shift 5, Option Tab, and